Alright, so today we're going to look at solving two-step inequalities. So just a reminder, when we're doing our inequalities, it's exactly the same as what we would do with equations, so we're still going to perform opposite operations on both sides of the inequality symbol. There are some differences, so remember, if you multiply or divide both sides by a negative value, that we need to flip the inequality symbol. And also when we do our verifications, we have two things to verify, both the boundary point as well as the inequality symbol. So we have to make sure that x is, or our variable is greater than or less than that specific boundary point that we state. Okay? Alright, so let's look at our first example here. I'll start off with one with integers, and then I'll do a decimals, and I'll do a fraction. So if you want to skip to the one that most interests you, or the one that you're going to be trying to work on this week, then by all means feel free to flip to that one. Okay, so with this one I've got 4x plus 13 is less than 37. So I'm going to start off by removing the constant from both sides. So the opposite of positive 13 is negative 13. So we subtract 13 on both sides. And now we have 4x is less than 24. Okay, 4x, that's our coefficient, so we're going to divide both sides by that coefficient of 4. And so now we have x is less than 6. Okay, so again, what I'm saying with this is any number that is smaller than 6, okay, is going to make this original statement true. So as long as the number I pick for x is smaller than 6, it should make that original inequality true. Okay? Alright, the first thing I'm going to do is I'm going to verify that that actually is the correct boundary point. Okay, so 6 is the correct boundary point. So we're going to do that by verifying just like we did with equations. So I'm going to say on the right hand side we had 37, on the left we had 4x plus 13. And what I'm going to do is I'm going to substitute in that value of 6 instead of x. And so now I have 4 times 6 plus 13. 4 times 6 is 24, and 24 plus 13 is 37. Okay, so there we go, we have the correct boundary point. Now the second thing to check is to make sure that our inequality symbol is facing the correct way. Okay, so I have said x should be less than 6. So I'm going to actually pick something that is smaller than 6 and see if it works. Okay, now again, my favorite is to, if possible, I'm going to try 0. So it's true that 0 is smaller than 6. So I'm going to try using 0 in this case, okay, to see if it makes my original inequality true. So that original inequality, we had 4x plus 13 should be less than 37. And I'm going to put in that value that we said we're going to try. We're going to put in 0. And I don't need to pick 0. As long as the number that I picked is smaller than 6, it's going to work. Okay? Or I want it to work. So 4 times 0 is 0. 0 plus 13 is 13. And 13 is less than 37. So I right now have a true statement, which is good. What I want is to get something here that is true. So because that's a true statement, it means the inequality symbol is facing the correct way. Okay, so the solution to this inequality is x is smaller than 6. So I have the correct boundary point, and any value that is smaller than 6 is going to make that original inequality true. Okay, we'll do another one here with decimals. Alright, so I got 7.2 times r minus 5.6 should be greater than 5.2. Okay, so I'm going to start off by getting rid of the constant. So I'm going to add 5.6 to both sides. And this now leaves me with 7.2 r is greater than 10.8. Okay, and then we're going to divide both sides by that 7.2. And that leaves us with r is greater than 1.5. Okay, so again, that should be all my solutions. As long as I pick something that is bigger than 1.5, I should get a solution that is true for that inequality. Okay, so I'm going to test that out. I'm going to just make sure that we have the right boundary point. Okay, and so we had started with a 5.2 on the right, we started with 7.2r minus 5.6 on the left. So when we substitute that 1.5 back in to our expression, and then we're still taking away the 5.6, this is your chance for you to double check on the calculator. So 7.2 times 1.5 is 10.8. 10.8 minus 5.6 is 5.2. Okay, so we have the same value on both sides, meaning we have the correct boundary point. So now we just need to make sure that our inequality symbol is facing the right direction. Okay, that we've actually identified the side that is bigger than the other. Okay, so we said here that r should be greater than 1.5. So I just need to pick something that's bigger than 1.5. Now you can pick whatever you want. I just try to pick easy values. So I'm going to try to pick something that's easy, where I'm not going to need a calculator to help me. I'm going to make r 10, because I think multiplying by 10 is pretty easy, right? So if I've got 7.2r minus 5.6 should be greater than 5.2, I'm going to now substitute in that value of 10. And again, I just picked whatever I thought was going to be easy. You don't have to pick this. You could have picked 1.6 because that's bigger. You could have picked 5 because that's bigger. Doesn't matter what you pick as long as it was bigger than 1.5, because that's what you're trying to test. Okay, 7.2 times 10 is 72, and I don't need a calculator for that one, which is why I picked 10. Okay, and 72 minus 5.6 is going to give me a 66.4, and that is definitely bigger than 5.2. Okay, so I have a true statement here, which means my inequality symbol is facing the right way, which means I have the correct boundary point with the correct inequality symbol. So this is the whole solution for my original inequality. Okay, one more with fractions. Oops. Alright, so with fractions we might have a little bit more work to do. Okay, same thing, I'm going to get rid of the constant like I did before. So I'm going to get rid of this 1/3. It's positive, so the way to get rid of it is to subtract it. Now this one does not come as easily as some of my other numbers have. So 3/5 minus 1/3, I don't know that off the top of my head. So if you don't know what that's going to be off the top of your head, move that work off to the side and figure out what it's going to be. So 3/5 minus 1/3. Okay, well, they need a common denominator. So I'm going to rewrite that instead. I'm going to write that as 9/15 minus 5/15. And 9/15 minus 5/15 is going to give me 4/15. Okay, so I'm going to come back to my inequality now. Okay, and on that left-hand side, I'm going to write 4/15. And on the the right-hand side, we have negative 1 3/5 y. So I'm going to change this one. I don't want to write it as 1 3/5. I'm going to rewrite that as 8/5, or 8/5. Okay, I like to work with things as improper instead of mixed. Okay, so I write that as negative 8/5 y. Okay, so my coefficient for y is negative 8/5. So remember, I'm going to multiply both sides of my expression by the reciprocal of the coefficient. Okay, so I'm going to multiply both sides by, in this case, negative 5/8. Now, because I'm multiplying both sides by something negative, I'm going to make sure that I flip my inequality symbol. So he started off saying the right-hand side was bigger. Now the left-hand side must be bigger. Okay, so take care of that first before you forget. Alright, I've got some cross-reducing I can do with this fraction here. So I get a 1 and a 2, and here I get a negative 1 and a 3. So I end up with negative 1/6, and on the other side I just have y. Okay, so in this one I'm saying that the solution to that original inequality should be negative 1/6 must be bigger than y. Okay, oh sorry, throughout the whole thing I forgot there was the line underneath. So it's negative 1/6 should be greater than or equal to y. Alright, so first thing we're going to check is we're going to check that that is the right boundary point. Okay, so we're going to go check on the left side and the right side. This time the left side started out as something nice and easy. It's just 3 over 5. On the right hand side we had 1/3. We took away 8/5 times y. Now I'm going to replace that y. I'm going to replace it with -1 over 6. Okay. Now this one here, so if I'm looking at just my multiplication, okay, I have 8 over 5 times -1 over 6. So I know that's going to give me a negative answer. But I also have this negative sitting out front. Okay, so what I could do is I could write this as plus negative 8 over 5. So I'm going to rewrite this now as plus, and I got a negative 8 over 5. And now negative times negative is just something that is positive. Okay, when I do my cross reducing, here I get a 3 and a 4. I don't know if you'll be able to see the yellow. I apologize if you can't. Okay, so now I've got 1/3 plus, and now I get 4 over 15. Okay, well I need to change the 1/3, so I'm going to write that as 5 over 15 plus 4 over 15, and that is 9 over 15, and 9 over 15 in lowest terms is 3 over 5. Okay, so a little bit more work to figure out that yes, we do have the right boundary point, okay, but -1 over 6 is the correct boundary for this. Okay, so the second part, I now need to try something that is actually less than -1 over 6. Okay, so we said -1 over 6 is greater than or equal to y. I have to pick something that's actually smaller than 1.6 now. Okay, now when I look back at my original inequality, y is being multiplied by something with a denominator of 5. Okay, so I'm going to try and pick some multiple of 5 for y. So I'm going to try y equaling, let's say just -5. That should be easy. Okay, so I'm going to rewrite my inequality as it started. Okay, and it's minus, and we've got 1 and 3 over 5 y. And now I'm going to change this so that instead of working with y, I'm now working with -5. So it's 3 over 5 should be less than or equal to 1/3 minus 8 over 5. And instead of writing y, I'm going to write -5. Okay, so just like we did when we were verifying before, I'm going to rewrite this as plus -8. So now I've got -8 times -5, so I'm going to get something positive. The 5 and the 5 are going to cross reduce, and they just become 1s, so that's very simple, because now I just have 1/3 plus 8 should be greater than or equal to 3 over 5. This one should be pretty obvious that it in fact is. Okay, so we have 3 over 5 is less than or equal to 8 and 1/3, which is true. That's exactly what it is. Okay, so this was a true statement, and since that's a true statement, it means that our inequality symbol is facing the right way. And since our inequality symbol is facing the right way, our original inequality that we had, I'll rewrite it out because we've got lots going on here. Our original inequality that we had, so we started with 3 over 5, was less than or equal to 1/3 minus 1 and 3 over 5y. The solution to this inequality is all of the numbers that are less than or equal to -1 over 6. Okay, so that's solving inequalities that involve 2 steps. So again, same process as equations, just make sure that you're watching if you multiply and divide both sides by a negative.